Most of my career, I've spent working on short-lived campaigns at creative agencies. And although I learned a lot there were certain things that I didn't really get to learn there. For example, maintainability of software, scalability. So when I joined a product development team about 2.5 years ago, I had to change my attitude towards software quite a lot. With hundreds of thousands of monthly active users, all of a sudden, the quality of your delivery becomes a lot more important than the speed at which you deliver. So what I've learned in the last couple of years is what I wanted to talk to you about today. My name is Iris. I'm originally from Austria, but I've kind of lived all over Europe over the last couple of years, and currently I'm based in Stockholm, Sweden. This is my Twitter handle in case you want to follow me or, watch me rant about things every now and then. And although I have arguably the worst taste in music ever, I somehow managed to land a job at a music company. And in case you're not familiar with Spotify, we're one of the world's biggest audio streaming services with about 60 million tracks, including 1.5 million podcast titles. And with almost 300 million users, you can imagine that any edge case that you can or can't think of will happen for quite a lot of people. So we've had our share of extraordinary bugs and bug fixes, like, for example, in 2009, when John fixed Eric's matrix factorization job by installing curtains in the server room so they wouldn't overheat. I personally don't write matrix factorization jobs, but instead my team owns the Premium Family, Premium for Students, and Premium Duo products on the main Spotify.com website. And those are the flows that I will show you today, or the bugs that I will show you come from these flows. But speaking of bugs, how do we actually find them? This is what I call the bug finding pyramid. And at the lowest levels, you have automated testing in type systems, as well as manual and exploratory testing. So all of that happens before you deploy to production. After that, we have monitoring systems. And at the end, we also have our users complaining, for example, on Twitter or to our customer service. And in an ideal world, all of our bugs would be found in the first 2 layers. And as few bugs as possible will be actually exposed to the user. And how do we make it? How do we ensure that we avoid exposing bugs to the user? By investing in those lower levels of the pyramid. And that is what I want to talk about today. Specifically, I want to talk about front-end testing, because for some reason, 36% of front-enders still didn't test their code in 2019. And to make sure that we're off for a good start, let me first introduce a couple of ground rules that I like to think about or keep in mind when I write my tests. A good test has a couple of characteristics. It should be readable, writable, isolated, fast. But the most important rules for me are the following. Number 1, will the test fail when something goes wrong? If it doesn't fail if something goes wrong, what's the point of even having the test? And there's another important question that we can derive from that, which is which parts can go wrong in which ways? And we can use that to decide which test cases to cover, what scenarios to actually test. The second question is, will the test only fail when something goes wrong? And this is almost equally as important, because tests are code too. And if we have to constantly change our tests so they don't fail, first of all, we're wasting a lot of time, but also we lose a lot of trust and confidence in our tests. So treat your tests like you do your normal code, make it as maintainable as possible. And the way we do that is by testing the public interface. So if we only test the public interface, we can ensure that we only have to update the tests if something actually has to be updated in other parts of the application as well. And with that, let's look at the first bug, parental control lock not updating. Within our app, we have this explicit music filter where parents can allow or disallow explicit music for other people on the plan. Unfortunately, while developing this feature, this is what I was seeing. It loads and it jumps back. So what was wrong? In our application somewhere, we have this data structure. And we have this allow explicit music true flag or false flag. Unfortunately, after communicating with the backend, this flag was not updated accordingly. Luckily, this never made it into production because I wrote a unit test for it. And unit tests are tests that cover or test the functionality of one unit, in this case, the toggle filter function. The toggle filter function just takes an old state, an ID, and returns a new state. And this toggle filter function is a pure function because it only has two inputs and one output. No matter how often you call it, given the same inputs, it will always produce the same output. And what I love so much about these pure functions is that, first of all, they're extremely easy to reason about. They're very simple to understand, but also they're very simple to test. And how do you test them? Well, given the same input, you have the same output. So you can give it some input and assert that the output is something like here. We first set up the data that we want to pass in. So a members array with one user to remain the same and one to be updated. We then set up what our expected outcome should be. And mind you, the allow explicit music flag is updated from false to true. We then actually call the function. And lastly, we compare the output of the state after data.member to the expected members that we set up before. So, time to ask our two questions. Will the test fail when something goes wrong? Yep. Will the test only fail when something goes wrong? Unless your business logic changes, yes. And in that case, we obviously want to update the test as well. Some of you might now be thinking, I thought this was about testing UIs. Let's look at another bug, forever loader. So this is what users were seeing on a specific case for some time. And the reason for that is that we have this page component, and the error that we had was occurring inside of the logic that sets the isLoading flag. And because of that, isLoading was never reset, but there was an error on the page. But rather than displaying that error, we just showed this loader forever and ever and ever. Well, how do you test something like that? Well, if we go back to our toggle filter function, our pure function that we talked about before, it turns out React components don't look all that different. We have a component that takes props and returns a React element. So we should be able to do something like this. We render the page and expect the outcome to be something. We could, for example, use Enzyme for this. And in this case, we are mocking the error page. That means we are replacing the error page with a fake one that will know when it has been called and with what. And in this case, we want to assert that it has been called with the error as a property. Now, will this test fail if something goes wrong? Well, if we don't use a proper type system, then the error page's props could change without the test failing. So that's not ideal. Will the test only fail when something goes wrong? Again, it kind of depends. If we render the component in a different way, say you use a different error component inside, although nothing will change to user, the test will fail. There's also another way of testing this component, which is a little bit closer to what a user would do if a user were to verify that this works. In this case, we're testing if the something went wrong text is actually included in that page. And we're using React testing library for this. Will this test fail when something goes wrong? Mostly yes. Strictly speaking, something else could fail as well in the rendering of this page, and the test would still be green, would still pass. But to the user, it doesn't really matter if the error comes from this or from something else, the result will be correct. Will the test only fail when something goes wrong? Again, it kind of depends. If we change the way that the error is rendered, if we change the copy, etc., then the test might fail, although nothing has actually failed. Now, the question is, should we mock or not? Which one is preferable? And it really depends. If your error page, for example, is a component that you use everywhere throughout your application, then I think it's fair to assume if you've called the error page, everything should be fine. If, however, you consider that error page to be a bit more of an internal concern of that page component, maybe it's better to actually assert that the outcome or output to the user is correct. So pick that route. Generally, the less you mock, the closer to the real world your test will be. On the other hand, it might get harder to find out what is actually failing if something fails. When in doubt, always ask yourself, how can you write a test that will catch bugs, but that you don't have to update constantly? And with that, we can go to the next bug, member page not opening. You've already seen the member page in the last bug, but this is how it is opened. Ta-da. Unfortunately, while refactoring this page, this happened instead. I was passing in the wrong function somewhere, and because of that, things were just not happening. However, because before I started refactoring, I wrote an integration test, I caught that problem right away and knew that there were no regressions. So what is an integration test? An integration test is kind of like the unit tests we looked at, but they test several units in integration. Some people might actually argue that the test we saw before was already testing both the error page and the page component and should already be an integration test. We like to put our integration tests a little bit higher level. So rather than just rendering one component, we would render an entire page usually. And the only part that we still want to mock or replace with a fake object would be the API response. So that's what we're doing here. We're setting up a fake family plan in this case, and that is what is going to be returned by the API layer. Then we actually render our application at a certain URL. We wait for the Manage Your Family Plan page to appear. We then click on this member, in this case called Ashley. We then wait for this page to appear and press the back button and wait for us to be navigated back to the original page. And I'm using Jest and React testing library for this. Will this test fail when something goes wrong? Unless the API changes, so unless your response from the backend changes, this test will fail when anything bigger goes wrong on your front end. And if you have a lot of these API responses that you have to mock or stub, I recommend using something like Netflix Poly.js, which can actually replay HTTP requests for you and store those in fixtures automatically. So you can be sure that you're always in sync with your backend, which is great. Will the test only fail when something goes wrong? Again, it kind of depends. If your copy is changing, you rely on roles, ARIA labels, maybe even test IDs, things like that. So if any of those change, your test will also fail. However, to me, that is a change that is, that users are affected by. So I'm happy to update my tests in those cases. Cool. Let's look at a different technology that can be used for the same kind of test. In this case, we use Cypress, and Cypress moves up a level more in the stack. So now we're actually testing on the browser directly already. And again, we intercept the call to our backend because we still don't want to interact with that, and replace the data returned by that API with a fake one. We then visit our actual web application, let's call it that. And then we again assert that we're on this page. We click on the member. We make sure we land on the next page. We press the back button, and we want to be back at the other page. And like before, this test has the same advantages and disadvantages as the last one. So if you change the copy, you might have to change your test as well, etc. However, one thing that Cypress does exceptionally well is it comes with a visual debugging tool that looks something like this. And in that, you can watch the test run and hover over each step to observe exactly what is happening. And that is really, really helpful for debugging your tests. Let's look at what that looks like. Cool. All right, now we've fixed 3 bugs already, made sure that they can never return because we have tests for them. But that day, the person who was on call on my team got paged because the student discount renewals were plummeting. Turns out that big parts of Spotify.com rely on PHP and Bootstrap. That's the legacy part of our website. As we were launching India about a year ago, we added a new flag, the flag of India, to our Bootstrap bundle or distribution. Unfortunately, the build failed, but somehow still made it into production. And that had the effect that all JavaScript related to Bootstrap, in this case, for example, our modules, started to fail. So this is what the flow looks like usually. We press next here and we should see this module. And on continue, we go to our student verification partner, SureID. However, on that day, instead, users were experiencing something like this for about 2 hours. Nothing happens. All right. Unfortunately, our tests did not catch this. Instead, our tests helped debug this problem. And in particular, it was our end-to-end tests that helped us out in this case. So what is an end-to-end test? They are the tests that most closely resemble manual testing. You're actually in the production environment or a environment that closely resembles production, and you click around programmatically like a user would. And that sounds a lot like our tests from before, right? Our Cypress integration tests. Turns out by just actually creating a real user and logging that user in and navigating to the real website rather than just a local one, we basically make an end-to-end test out of our integration test. In this case, for redeeming student discounts, the test would look something like this. We first create a student user and log in with that user and set them in the last year of their student discount. Then we visit the testing environment. These functions, by the way, are all shared between different teams, so everybody can use them. We then make sure that we land on the landing page, click the first CTA, go to the next page, ensure we are there, click on renew discount. We then check that the path name changes, and we land on the right page. We click next. We ensure the module opens, and that on clicking continue, we land on ShareID, our verification partner. Cool. So will this test fail when something goes wrong? Yep, absolutely. It will. And these are especially useful for the parts where many teams contribute to the same code base or to the same flows, because there's so many different interactions that can go wrong. That is, however, also the weak side of these tests. Will they only fail when there's something wrong? No, because there's so many different things that could be flaky, these tests can end up being somewhat flaky as well. They also take a little bit longer to run usually. So we don't run them as part of our continuous integration pipeline, but instead after deploying to production. So although they're an extremely useful tool for debugging what is happening or what is wrong, and for just double checking, sanity checking that everything's still working, we personally don't run them as part of our continuous integration pipeline. All right. Now we've talked a lot about different kinds of functional bugs. Maybe you're thinking, what about the visual ones? And visual bugs for me for a long time were the hardest to find, especially in the legacy part of our website, where we use Bootstrap everywhere. A simple change in CSS could have fatal consequences, like here, where we changed one line of CSS and all of a sudden the checkout looked entirely broken. But it's not only in the legacy pages that we have these problems. This button, for example, is absolutely haunting me. It's been falling down underneath this navigation bar, I don't know how many times. And whenever we try to push it up again, 3 days later, it will be lower again. So how do we prevent these kind of problems? One way is through snapshot testing. And a snapshot test is basically rendering a component to a file, and then on later changes, making sure that that file still looks the same. These files look a little bit like this, or rather like that. They get extremely, extremely long. This particular one, I think, has 1,800 lines. And that is exactly the problem that I see with these tests. Will they fail when something goes wrong? Absolutely. But will they only fail then? No, they fail on absolutely any change. And because they fail so often, and because the changes are so big that not even GitHub wants to display the diff anymore by default, they become a bit error prone, people start ignoring them rather than really relying on them. And the only thing worse than not having tests is tests that you can't rely on, but that still give you a false sense of security. So is there a better way? I think so, yes. Automated visual regression testing. So just like the snapshot tests, we're now taking screenshots instead of capturing the outcome in HTML and CSS. And what we do at Spotify is do this on every branch for every story in Storybook, and then compare those screenshots to the screenshots we have on the master branch. This is the tool that we've built in-house. This is one of the modes that you can look at. And as you see here, you get the summary of all the things that have changed directly on your pull request, which is extremely useful. You can build this in-house, or you can use a tool like Percy or Loki or Storyshots if you use Storybook, or you can write your own using something like Backstop.js or Cypress with Puppeteer. And again, will these tests fail when something goes wrong? They don't really fail, it just report that something has happened, that something has changed. But yes, will they only do that then? No, like the snapshot tests before, they will fail on any change whatsoever. However, at least to me, it's a lot easier to look at 20 screenshots and compare them than to look at 200 or maybe 2,000 lines of CSS that have changed. And one caveat with these tests is that sometimes if you have a lot of animations, they might get a little bit flaky. So what we've had to do is disable animations. All right. Those were all the bugs that I've prepared for you for today. Where do we take it from here? First of all, I hope that I could show you that testing frontends is not as daunting a task anymore as it used to be. There are a ton of tools out there. I hope I could show you a couple of them really quickly. They're all really well documented, and there's really just no excuse not to use them anymore. If you still don't know where to start, take the 2 questions that I've introduced you to and just focus on trying to find a solution that maximizes the effort to confidence ratio. Because at the end of the day, that's what testing is all about, giving you confidence that your application works. And if you ask me, we owe it to our users to have that confidence. Thank you.
Thank you so much for being here.
Thank you for having me.
Of course. I have actually a couple of buddies / ex-colleagues that joined Spotify recently. So see if you can find them. So shout out to Simon and Aaron and Artie. But thank you for your talk. Let's get right into it because we have a ton of questions. All right. So the first question is, are you using these techniques as part of test-driven development or creating these tests after you have developed your functions?
I personally don't really do TDD unless when I'm fixing bugs. So if I see something's wrong, then I'll first write a test for it to make sure I catch the bug and then fix it. So I see, the light going from red to green. If I develop a new feature, it kind of depends. If I see something like, okay, this might be hairy, then I might write the test first, but I don't always do it. And there's no rule you have to do it like this at Spotify, as far as I know.
Yeah, that's a pretty good shout. Speaking of you at Spotify, there's a couple questions about your process. With a scale as large as yours, this is kind of like a 2-parter. One is, do you run tests on commit or push? And if yes, which ones? And 2, does it take a really long time to run all of these tests? And is there a way to make that better?
Right. If you think about, microservices in the backend, we're trying to also keep our front end somewhat small. So my team owns this part of the website, and we have around, I think, 1,000 tests covering that. And they run in maybe in the pipeline, it takes under 15 minutes. So it is not the fastest, but it's usually okay to wait for 15 minutes at least in our team before you can merge. So we run them as part of our pipelines, and you can't merge if the tests aren't green, of course.
That's pretty good. And then do you run any on commit versus push?
While I'm developing, if I'm writing tests, which is what I do while I develop, I also run at least the unit tests. If I'm writing unit tests, I'll let the unit tests run in watch mode. while I write the tests. If I write Cypress tests, I have my Cypress window open next to my editor. So yeah, it's not on commit, it's while developing, and then also in the pipeline on push.
Amazing. Safety first, right? We have one question. Do you have any plans to open source the visual regression tool you showed in your talk?
That's an interesting one. I think that they have thought about it. It's not my team that wrote it, but now we're considering actually switching to a paid tool. So I don't think we're going to open source this one for now.
You might even stop using it.
Exactly.
It is very helpful though. That's really cool. Because you've shown us a couple of bugs that your tests caught, which is, I think the greatest proof that tests are really important. But have any of your bugs ever made it to prod?
I'm sure they are still there, even some of them. But one that I can think of is, so the part of the website that we work on, we include our SPA inside of like a bigger application, the account platform. And because of that, if you say style something with 100% height, that might not be the same in your SPA and in your storybook as it actually is on the live website. And because some of our tests, or most of our tests, only run directly in the SPA, I once accidentally pushed something that made the entire website scale like in a really weird way. Luckily, because I knew that was a risk, and because we run our visual regression tests only for the SPA, I did check it right after deploy and rolled it back directly afterwards. So it's still somewhat caught it quickly, but yeah, my bugs make it into production like anybody else's.
Yeah, I've had a ton. I'm not going to talk about them though, because it's in the past. It's in the past.
At the same time, right? It's no blame as well, because like,
of course not. Yeah.
I review everybody else's code and everybody else reviews my code. If something goes in that is, that causes a bug, it's all of our fault, not just the one who wrote the code. So
yeah, for sure. We got a couple more questions from the audience already. So Lee asks, do you always mock APIs when running integration tests and only call the actual API in end-to-ends outside your CI flow?
For my team, that is true, yeah. But mocking, in this case, we use a tool called poly.js. So it basically just calls your actual APIs and then stores the response on your end. So that is to just reduce the risk that the API changes while the front end doesn't as you develop. It's not really a guarantee after you deploy, but at least as you develop, you would notice those differences.
Do you usually write any tests to check for backwards compatibility of your front end to the back end?
No, because versioning of APIs takes care of that usually. We've not run into any problems with that so far.
Nice. Floros asks, can you implement visual regression without having the components in Storybook?
Absolutely. We actually in the beginning didn't really have Storybook. We just built our own little page where we demonstrated components, which is kind of what Storybook does, right? It was a lot less pretty. It was a lot, it didn't have an API or anything, but it works. And even if you just give it live URLs, if you don't have a login or something, as long as you have a tool that can take screenshots and you give it some URLs, you can do visual regression testing.
That's awesome. And I think there are some tools that you recommended in your talk, right?
Yes. So Percy, I know, does it. Loki Story Shots, I think, is another one. Or I think Backstop.js is a tool that you can use for taking the screenshots or for comparing the screenshots, sorry. And then you can just use Puppeteer or Cypress or any of the end-to-end test framework for taking screenshots of your website.
Awesome. Gaddy asks, how do you make sure you don't repeat the same tests with unit integration into an et cetera?
Huh.
And has that ever happened to you, I guess?
I don't think so. Like, maybe. I've never it's never been a problem, at least. We do sometimes, copy and paste around a little bit, but even there, like, because tests are also code, we try to keep it dry at least a little bit. So to not run into that problem, we would try to actually extract some of the tests into some utility function or something. And then your test becomes readable again. You avoid, copying the same code around several times.
And I mean, worst case, you just have more tests, more backups. Right.
Exactly. It runs a little bit slower, but better double than none, right?
Yeah, exactly. We have another question here. Where would you recommend starting if you've never done testing before? And have you ever considered creating a course, because they loved how you explained everything?
Oh, that's so nice. Thank you. I think two things. One way to start testing, I think, is through end-to-end tests. If you just want to make sure, or get buy-in from someone, just showing that you can write an end-to-end test for your most important flow in 10, 15 minutes in Cypress or some other tool. And then you don't have to manually test it every time you deploy, which, is huge. The other thing that I would recommend is if you decide to start testing, every bug you have, write a test for it first, so you know that it will never come back, right? So you're
ensuring a great against
regressions. Yeah, those would be the two things that I would start with.
I have one last question, real quick, because we're running out of time. What's your perspective on test coverage, and whether you have any test metrics that you use?
We do look at test coverage, but mostly from a perspective of what do we not test. I don't think test coverage is a great metric to show, okay, now I have 90%, now I don't have to test anymore. That's not very helpful. So we don't have like an exact number of this is our target or our goal. It would be different, I think, if we were developing say a tool for someone else rather than an end user facing website. But yeah, what we do use the coverage for is definitely finding holes or things that we don't test well enough.
Yeah, that's awesome. Well, thank you so much, Iris, for joining us. And Iris will be in a Zoom room after this, I think, if you still have more questions. Have a great evening.